We will start our session in a few minutes. We will give people some time to join. Thank you very much. Well, hello everyone, and welcome to the second session of the BDR webinar series. My name is Monica and I am part of the marketing team here at EDB. I will be your host for today's session, Upgrade Easily with BDR. I'm joined by Simon Riggs, PostgreSQL Fellow here at EDB. Before we get started, just a few housekeeping items. The presentation is being recorded. We will be sharing the slides along with the recording after the broadcast. The lines will be muted during the entire session. If you have any questions, please use the Q&A tab located at the bottom of your screen. We will allocate extra time for Q&A at the end of the session. If there is not enough time to address all questions, we will follow up afterwards with any attendee whose question was not answered. And now, without any further ado, Simon, over to you.
Thank you very much, Monica. So this was a presentation that I'd written in August to highlight the importance and details surrounding the upgrade process within Postgres BDR. And I'm giving that same talk again now because a lot of people were very interested in it. So Postgres BDR is often described as a advanced replication solution, and we focus on different parts of it really, and it's difficult to know which parts are of interest to people. So very often we talk about the high availability aspects, and I will be talking a little bit about that here. But really, the feature that we're focusing on, the reason we're having this whole presentation today, is to talk about the ability of BDR to upgrade your applications and your databases with near zero downtime. And this is really a very important capability that differentiates it significantly from just normal physical streaming replication that you would get with core Postgres. So it does other things as well, but it's the upgrade that we are going to talk about today. So the software stack is important to understand. The database runs on top of the operating system, and the application accesses the database. So in this sense, the database includes BDR because BDR is an extension, so it plugs into the database. But all of these components need to be able to be upgraded, and so we need a way that allows that to happen. Okay. So we're not just talking about one of these components, we're talking about all of them in different aspects. Why upgrade at all? Well, 10, 15, 20 years ago, it was very normal not to upgrade very often. And as a result of that, we have quite long support durations still in the industry. For example, Linux LTS kernel is supported for 6 years, and even super stable Postgres releases are supported for 5 years. So if things are supported for that long, why upgrade? Why not just wait 5 years until you're forced to upgrade, and then and then upgrade then? What is the requirement to upgrade? Well, where that comes from really is security and compliance. Security itself is better served if you upgrade your components to the latest releases. And more specifically, compliance directives now are requiring people to upgrade their servers within a certain period of time of new software arriving. And as a result, that means that instead of upgrading once every 5 years, we now have to upgrade much more frequently, possibly every 3 months, or maybe even more frequently than that. And if you look at that, that means that we're upgrading now about 20 times more often than we used to in the past. And so upgrading becomes much more of a key capability than it was in the past. So, you can see that there's the requirement for upgrading is there. But the question that BDR asks is to turn this around and say, what's the problem with upgrading? Why would you not upgrade all the time? And that's the capability that's been built into to BDR. Now, where did I get these numbers from? Well, if you look at the upgrade frequencies, you'll see that the Linux kernel is updated roughly 5-6 times a year. In 2020, there were 6 maintenance releases. The Red Hat updates come out twice per year, but you might operate on a different kernel to that. Postgres database maintenance releases are now fixed on a schedule of 4 times per year, and security fixes are fed into that maintenance release process. So you will find it fairly difficult to avoid upgrading for security reasons, even if you didn't think that the maintenance release affected you. So if you take all of that together, that means that you will be upgrading on a fixed schedule somewhere between 2 and 6 times per year. But that's assuming that you don't experience any bugs. And obviously, if you have a bug and that bug needs to be fixed, then you will be upgrading more frequently than that. Now, some of you will say, what do you mean upgrade more frequently than Postgres releases? What are you talking about? Well, that's exactly where EDB support comes in. Or presumably there are other companies as well that do this, but EDB support is break fix support, meaning that we will take a bug that you've experienced, we'll write a specific patch just for you, and we will ship it to you. We're not going to wait 3 months until the next maintenance release. We'll ship you that fix very quickly, possibly to a defined SLA, depending on exactly the nature of it. And so if you get a bug like that, you will need to upgrade for that as well. So if you take into account all of those sources of upgrade, I think it's a very reasonable expectation in the modern age that you will be upgrading your systems 6 times a year. And of course, some people who want to talk about DevOps might laugh at 6 times a year and say, 600? Well, that's cool. I mean, I've got no problem if you want to upgrade more frequently. That's beautiful as far as I'm concerned. There's no restriction in BDR on how frequently you can upgrade. What I'm trying to put the case forward is that you need to plan to upgrade frequently being at least 6 times a year, okay? Because there are still some people that don't believe that they need to upgrade more frequently than every 5 years. So that's those are the people I'm talking to here. I'm not talking to the people that are already committed upgraders. So that's how often we need to upgrade. And so clearly, we want a solution to the upgrade process that makes it go smoothly and minimizes the effect of the upgrade on the other system components, and obviously on the business service that the software provides. So what I'm going to do now then is take you through some more details about how BDR works with regard to the upgrade process. And then once I've done that, I'm going to go into a lot more detail about the exact steps and how that works. So Postgres BDR is EDB's strategic clustering technology. It's used by many customers in critical production deployments, by which we mean that's the business critical system, mission critical systems on which they run their business. BDR is supported in 2 main release streams at the moment. The 3.6 series runs on Postgres 10 and 11. The BDR 3.7 runs on 11, 12, and 13. And in the future, BDR 4 will run on 12, 13, and 14. So we've already got plans to release BDR on top of the forthcoming Postgres 14, which isn't released yet, but I'm just letting you know ahead of time because, of course, it is coming out fairly soon. BDR also runs on a couple of different versions. You may remember that EDB has a product called EPAS, or EDB Postgres Advanced Server, and BDR runs on Advanced Server as well as the more normal Postgres versions. So the architecture that we have with BDR is variable. BDR supports quite a wide range of architectures, but the one that we talk about most is called the always-on architecture, and that is the diagram that we have in front of us there. So the BDR system comes with a number of different servers in the mix. For example, it's got session pooling, it's got high availability detection, it's got backup, it's possibly got additional analytical servers, but the core of BDR are the 4 servers in the middle of the diagram, and specifically the one at the top left marked BDR1 is what we call the lead master, and that's the one that you run your application against. So the design of BDR is multi-master, and that allows the database to be active, meaning that you can run the application on any node. But the design of this specific architecture is that we run the application against only one node at a time. Now, that seems strange to have a system where you can access any node, but then you don't. But of course, the reason is that we do that is that most applications are designed in the world of single master systems. And so this is effectively a single master system built on top of active technology. And obviously, BDR's got all the good things about it. It runs in multiple data centers, it's tolerant of down nodes, automatically recovers from node outages and network partitions. And it's deployed in an extremely consistent architecture using the tool TPA-exec, and that is built using Ansible, the one of the most popular configuration management tools in the industry. So everything I'm going to talk about today about BDR assumes this architecture. Okay, so if I lose you sometime later, please just think about this particular diagram, because this is what we're talking about. So I am assuming that we're using a 4-node database setup, which, you know, there's various reasons why you might sometimes want 3 or sometimes want 5 or whatever, but that's just too much information for now. So I'm just going to talk about one particular 4-node architecture. And very specifically, the capability that we are discussing is the ability to do rolling system upgrades. And we can do that in one of 2 ways. We can either do it automatically, or we can slow it down and do it manually. Now, what I mean by that, what I mean by rolling system upgrade, is we upgrade 1 node at a time, and we keep going until we've upgraded the whole cluster from the orange, which is the previous release, through to the green, which is the new level of release. Now that works across major software releases of the operating system, the database, and BDR. And it can be manually controlled as well, so that you can make sure to execute the upgrades on specific nodes, and as a result, switch your application across from node to node. So BDR doesn't know about your application, and so you have to program it in a specific sequence to get it to work, if you know, depending on exactly how your application works. And the way that BDR does this is that BDR connects all nodes to all other nodes. So in a 4 database node setup, you can see that there's 6 different communication paths that need to be considered. And what BDR does is it specifically renegotiates the protocol on each of those 6 links to ensure that the protocols are backward compatible. And so as the server gradually moves forward to having the whole cluster at the new release level, the protocols used will change between the different nodes. So it's quite a complex scheme, but it's very rational, actually fairly simple when you look at the details inside, but it does sound quite complex. So how does this all work? Well, you know, we don't need to look at what's actually happening inside the box, but we do need to know what the behavior of the system is while it's going through the upgrade process, and that's exactly what we need to look at here. Now, obviously, some sanity checks to begin with. We assume here that you already tested the application against the new version of BDR and that it passes those checks. And we also assume that you will test the upgrade script before running it on the live DB server. And these assumptions are why we think that you can run BDR as a high availability server, because of course, if you're not running in a suitably controlled environment, then you're not going to get high availability. You know, it is only when you're careful about the way you run your databases that you will run them in high availability. So, you know, safety first. Surprise, surprise, if you cross the road without looking, you're going to get hit by a car. So same thing here, okay? Make sure you test test for problems before you upgrade. So what does the upgrade process look like? Well, here's the basic outline. What I'm going to do is I'm going to apply this basic outline to a couple of different scenarios so that we can see what the steps look like in each of those cases. So the first thing we do is we do something with the application, okay? Now that's sort of slightly undefined at this stage because we're going to apply the same pattern to a number of different cases. But then we have to shut down the database and the server, potentially the server, perform the upgrade, and then start that up again. And then we do some more with the application. Okay, so it sounds a little vague, but we're going to follow that same pattern as we go through all of the different options. So I'm going to compare what happens with physical streaming replication versus BDR replication. And I'm also going to compare what happens with minor version upgrades and major version upgrades. So that gives us quite a few different combinations to talk about. So physical upgrade with a minor version, in order to do the minor version upgrade, we need to just handle the application by doing a switchover. So we issue a checkpoint. We allow time for data to flush to the standby servers, the replica servers. Then we can shut down the database, obviously with a clean shutdown. That's the point of doing the checkpoint first. Then we perform the upgrade. Then we can start up again. And because we did a clean shutdown, the startup happens very quickly. And then we can get back to using the application. Now, obviously, when you shut things down, the cache is not replenished. And so it will take a certain amount of time for the database server to get up to speed, and that will give you a slightly curving throughput curve as the server caches replenish. So that's what that looks like for a minor version upgrade. No problem, right? That's fairly straightforward. With a physical upgrade for major versions, then switchover is not possible. So you've got to perform a full shutdown. Now, why is that? Because the replicas can't follow across a major version upgrade. So when you do a major version upgrade, you need to completely replenish all of the servers to make sure that they are able to catch up. So you've got to shut down the server, you've got to perform your upgrade, and that will usually take at least 15 minutes for PG upgrade on a reasonable size server, and then you start up. And then once you've started up again, obviously you've got to refill the cache. And if you've restarted the physical server, then you'll have completely lost the operating system cache as well. And you probably need to reanalyze the database to ensure correct plans. And that can also take quite a long time, certainly more than an hour in many cases. So that's what you need to perform for a major version upgrade. Now, you may think, I don't need to do that very often, but what I'm saying is that you do actually need to do that often enough that it becomes a consideration that you need to think about and plan. So for a BDR upgrade, then that is just a minor upgrade of BDR itself. You just need to do a switchover. Notice that in this particular case, you don't need to run a checkpoint because we're doing logical replication, not physical replication. So there isn't actually anything to worry about here. We can do the upgrade in place. But at this point, the application is online, so we don't actually have to worry about the fact that we're doing the minor version upgrade in place. Now, this is where it gets really good, because the BDR upgrade from major version is possible with just a switchover, because cross-version upgrade works perfectly fine with BDR. So notice this time we don't need to do the checkpoint. We allow time for data to flush to the high availability servers. We shut down the database. We perform the upgrade and copy across data to new nodes. Now, that does take potentially hours in some cases, but this is a very similar process to creating a new replica as you did with the physical upgrade. But the point is, while we do this, the application is online, and that's particularly important. So what I'm saying is that the upgrade, in terms of the effect on the application, the application is completely online. So while these things are occurring, we're not having any problems with downtime for the application. Now, what we're working on for BDR4, which will be out fairly soon, is the major version upgrade in place. And this is a new feature that will allow us to upgrade each of the individual servers within BDR in place, which means that it will also take 15 minutes. But the key point here is that the application is online while we're doing this. And so, this is not 15 minutes where the application is down and unusable. This is 15 minutes where the application is fully usable. Okay, so that changes the upgrade process from being a major source of downtime to no problem at all. And that's why we say it's possible to manage BDR with 5 nines, because of course normal services can be managed at 5 nines as long as you don't upgrade them, right? And that's the most difficult thing in the modern time, is to manage with those types of upgrade. And that's really what this is all about. So upgradability is a high availability feature, because that's what we need, is the ability to upgrade, the ability to add security fixes and such like, while we are able to maintain the availability of the systems. And other approaches don't give you that. Obviously, if you have an hour or 15 minutes of downtime, then you've blown the availability budget for the complete year by a long way. So you simply don't get more than about 99.9, maybe 99.99, but certainly not 5 nines. So let's have a look at what that means in terms of application design and how we do failover. So this is it's the case that all applications are not designed in an identical manner. Is your application designed to be session oriented, where you connect once to the database and then issue multiple transactions? Or is the application designed as a series of independent transactions, or transaction oriented? Can it use a transaction pooler? So how does the application handle concurrency? Can it run multiple app servers on different active nodes? And this is really one of the biggest issues with with applications now, because if an application is designed that the application can run from multiple application servers at the same time, then that means that you've actually considered the way that the application can work against a distributed active-active system. So a lot of applications are not yet designed that way, and that's why it becomes difficult with BDR to describe exactly what the availability is. So in some cases, if your application is aware of multiple nodes, you can give it multiple host names in the connection string. And if the first host name goes, then we can immediately switch across to the second node, and that will take, in some cases, less than 100 milliseconds. But if we're connected to the server with automatic failover, then we have to have a component that detects failover and moves all of the sessions from one node to the other node. If that's required, then the app can react in about 3 to 4 seconds. Now, either of those two options are still way better than the 30 to 90, in some cases 120 seconds that the single master systems quote. Now, why is that different? Well, with single master, it's extremely important that we get failover to happen correctly, because with a single master system, once you've failed over, you can't go back, okay? And that means that you need to be absolutely certain that failover is the right thing to do, because it's essentially a one-way process. And once you've done that, it takes a while before you could fail back. Now, as a result of that, we need to put quite a long wait in there to get things to happen correctly. And if you don't put that wait in there, then you get yourself into problem. Whereas with an active-active system, it's fairly easy to switch across and back and back and back without worrying too much about exactly what is happening. And that's an important capability with BDR. So some application architectures are effectively designed for single master, in ensuring that they then must experience downtime at switchover. So BDR allows a different type of application to exist, what you might call a multi-node tolerant app. So if the application can conceive of connecting to multiple nodes, all of which that are active, then it's very simple then in that case to have an app that has zero apparent switchover time, because if one node goes down, then the app already knew about multiple nodes, and it's fairly straightforward to get it to switch over. So BDR is designed to provide very high availability for all applications, but if you want to get even higher levels of availability, then you have to design your application to be what I call multi-headed or multi-node tolerant, in the sense that the application itself understands that there are multiple nodes in the system. And in fact, that's the same situation for any distributed database. So, as I mentioned at the start, the application architecture that we have with BDR is based around this, what we call the always-on architecture of the database. And this does not assume that your application has been redesigned. So a normal application that assumes only a single master is possible, will work perfectly fine with Postgres BDR using this architecture. So a couple of other things to mention about application upgrades and how they work. So the Postgres BDR system is fully automatic in regard to its replication. As you might expect, physical replication does automatic replication of changes, and so does BDR. So we have efficient log-based replication that is as much as 5 or 6 times faster than trigger-based replication on the origin. It's got a low overhead on the master node, low bandwidth, and there's quite a few different options that we have for asynchronous and synchronous behavior. The DDL with BDR is also automatically replicated, and we use fine-grained DDL locking to ensure that changes to one table don't interfere with changes on a different node. We also provide automatic sequence handling, which is provided by multiple different kinds of distributed sequence handlers, which make generating independent, not random numbers, identification numbers much more easy on BDR as a distributed system. So the DBA doesn't need to set up sequences specifically in a different way to make it work as you might do on some other systems. What's very interesting with BDR is it can replicate across schema versions, meaning that we can replicate between tables with slight differences. For example, if you have a column defined on one node as a varchar 1 to 8, and on another node as varchar 64, then we can still replicate between those two tables, even though the DDL is not exactly identical. And it's also possible to replicate with new columns added to tables. Now, why would you want that? Well, the thing is that these changes in the schema allow you to upgrade not just the database in a rolling manner, but they also allow you to upgrade your application schema in a rolling manner. This is known as rolling schema upgrade in BDR and some other places. So what this allows you to do is it allows you to run one version of your application against one node and a different version of the application against another, a different BDR node. And then what this allows you to do as a result is you can actually upgrade your application without taking the whole service down, because the application is running against different parts of the servers at the same time. So this is a particularly interesting capability. Now, obviously, this needs to be scripted. Okay, this is not kind of automagical. You need to get involved in writing scripts to make this work, but that's perfectly fine. I mean, the point here is that it gives you a level of availability that you really can't get in any other way. So a few final points before I finish up. How quickly must you upgrade? I talked about rolling upgrades. Well, how quickly does it roll? Well, BDR does allow you to upgrade slowly. There's no restriction on some sort of physical effect that needs to have the upgrade happen quickly. So you can upgrade one node and then wait for hours or days or maybe a week before upgrading each node of the cluster. And the reason I put the limit out there as a week is that there does obviously need to be some kind of limitation on how long you can leave it between upgrades, because BDR frankly isn't designed to run for years and years with different nodes at different release levels. But it is designed to work correctly across hours and days and weeks while we get the upgrade to work correctly in all cases. So yeah, it works very well. And the point I'm trying to make here is that if something goes wrong or you want to provide additional checks in the upgrade process, then that works as well. You know, it's not like you have to upgrade the whole cluster in the blink of an eye without checking. You can do it slowly, you can check again as you progress through a rolling upgrade. So it doesn't need to be a scary thing that rolls out of control. It can be something that you move forward slowly under full control to make sure that you're doing it safely and correctly. Now, all of these things taken together are also why, when we propose that you explore BDR technology, that you do that usually with an EDB consultant who's going to explain how things work and explain why they need to happen. And it's generally an exploration process that's taken together. So that might be called a proof of concept. But the essence is that you will have access to an EDB consultant to make sure that it's going smoothly as your first adoption of BDR technology. So that's it, fairly short and sweet. And now I'll try to answer some of your questions. I'm not sure I can answer all of them. Yeah, so the way that BDR works, it's completely agnostic of the data that you're using in your systems. So, for example, if you wanted to move from one table access method to a different table access method running Postgres, that's not going to worry BDR at all, because it doesn't work using physical storage techniques. It uses logical data level replication. So no matter what data types you're using, no matter how they are stored, what parameters they used, whether they're compressed or not, that's completely irrelevant considerations to BDR. So anything related to storage plugins or additional features certainly doesn't worry BDR at all. Okay, and that's obviously one of its great advantages, is it rises above those problems when it comes to making the upgrades work well. So if there are any further questions, then or if there aren't any further questions, then we can wrap up the session there today. So right.
I don't think we have any further questions. So I think this takes us to the end of today's session. And as I mentioned earlier, we will be sharing the slides and the recording of this session. Thank you very much, Simon, for this presentation. It has been very interesting and very insightful. And thank you very much, everyone, for joining. We will see you next week at the Ask the BDR Expert session, which will be presented by Simon and Gianni Cioli. So see you there.
Thank you very much.